Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we're going to talk about rational exponents. We talked about this earlier in nth root when we were talking about nth roots, but today we're just going to hone in on just rational exponents. Remember when we're talking about rational anything, they're trying to describe the fact that it is a fraction. So in this particular case, we're going to deal with exponents that are fractions. And you can write a radical expression in an equivalent form using fractional or rational exponents instead of a radical sign. In general, the nth root of x is 1 over n. Please, let's focus on a couple things. Let's remember that the x has an exponent of 1. It's invisible, okay? And when we're converting that radical to a rational exponent, it's x to the 1 over n. So think about it. It's x to the exponent of the radicand over the index of the radical. That's how it's going to be always, 100% of the time. So the nth root of x is always going to be turned into x, which is the radicand, raised to the 1 over n power, where 1, the numerator, is the exponent of the radicand, and n is the index of the radical. Okay? Like the radical form, guys, the exponent form indicates the principal root. So it's the same exact procedures as working with exponent form, always. So for example, I have the square root of 36. This is 36 to the 1/2. But Mr. Morrow, I don't see an index. Yes, I know. By now you should know that when a radical does not have an index, that is a square root and the index is 2. Thank you over there for showing me. Good job. The cube root of 64 is 64 to the 1/3 power. The power of the radicand was 1, 64 to the first power, and the index is 3, so it's the radicand raised to the radicand's exponent over the index of the radical. 4th root of 16 is 16 to the 1/4. Pretty simple. Now, let me give you every type of form that you can have here, so this way we will not have any confusions. The basic form is x to the 1n equals the nth root of x to the first power. Again, I know I'm repeating myself, but I want to make sure you understand this. When we're talking about the exponent, the numerator of the rational exponent is the exponent of the radicand. The denominator of the rational exponent is the index of the radicand, of the radical. So in that logic, x to the m over n is the nth root of x to the m. Which if you or you could really think about it, it's the nth root of x raised to the m power. Now, you may say, whoa. How did you get that? Well, let's think about logic and let's think about the exponent properties. What happens when you raise a power to a power? Good job. You multiply the exponents. So let's take this guy out here for a second. This inside part right here, the nth root of x becomes x to the 1 over n, raised to the m power. So I must multiply this outside exponent to this inside exponent, which would equal x to the m over n. And that's why these guys can be written either way. Yes, sir, my brother.
Distributing an outside exponent into like
You're raising a power to a power.
right.
You multiply the exponents.
Putting it into the numerator basically. Like you're multiplying.
Well, you're multiplying. So remember, numerator times numerator. So m times 1 is m. And then numerator times numerator, 1 times n is n. Thank you for verifying. Takes guts. Thank you. Okay, x to the negative m over n. This is the same exact stuff, guys, except you bring it down to the denominator to make it positive. So you literally went down to the denominator to make it positive, and then I have 1 over x to the mn equals the 1 over the nth root of x to the m power, and then from there I can rationalize to find whatever answer I need. Okay? All right, so let's do it. What would this be, guys? Hey, yes, sir, my brother. That's exactly perfect. Well done. 7th root of x cubed. Very good. Excellent. Can I simplify that, guys? Do I have 7x's that I can pull out? No, so we leave it like that. All right, what about this guy? Y to the negative 3/5. What do you think we would do first? Yes, sir. Make it an improper fraction. Very good, my brother. And what would that become, my man? Okay, no. This is 3 1/2, guys. 2 times 3 is 6. 7 over 2. Now, this becomes good. 1 over 7/2. Excellent. Which then this becomes 1 over the square root of y to the 7th. Which then this becomes, how many y's can I pull out, guys? Y cubed times the square root of y. Very good. And then if I had to, I would rationalize this. But for right now, we're just converting it to radical form. But in a real test or quiz, I would say evaluate this. And then at this point, I'd have to multiply it by the square root of y to both top and bottom to get rid of that square root in the denominator. Yes, sir. Thank you for your patience. The negative, since I had a negative exponent, my brother, remember laws of exponents. If I have a negative exponent in the numerator, when I bring it down to the denominator, I change the sign. If I have a negative in the denominator, I bring it up, I change the sign. In fact, the rule is positive or negative. If I bring a variable or any value, any real number or variable, from numerator to denominator, I change the sign of the exponent. Not the sign of the number, but the sign of the exponent. So if I have x to the third in the numerator, I bring it down, that's 1 over x to the negative third. If I have x to the negative third in the numerator, I bring it down, that becomes x to the third. So whenever I go from numerator to denominator, or denominator to numerator, I change the sign of the exponent. Not of the real number, but of the exponent. It does not affect the integer itself, the sign of the integer. Great question. Thank you, my man. Okay, next, my brothers. See what we got here. What about this bad boy? Very good, my brother. So this is going to be 1 over w to the 5/8. Excellent, my man. I couldn't have done that better myself. 1 over the 8th root of w to the 5th. Beautiful. Beautiful. Excellent. What about w to the 0.2? That's exactly right. That is 2/10, which is 1/5. So this is w to the 1/5. Beautiful job, my brother. And then that's going to equal, my brothers, my gentlemen, 5th root of w. Very good. Fantabulous. Awesome. That's not even a word, but it sounds awesome. Does that make sense, brothers? All right. Let us continue. Okay, again, just a brief reminder. X to the 1 over to the 1/nth is the nth root of x to the first power. X to the mn is the nth root of x to the m power, or the nth root of x raised to the mth power. And the x to the negative m over n equals 1 over x to the mn, which equals 1 over the nth root of x to the m. All right, let's convert all of these now into exponential form. Okay, I went from exponential to radical. Now let's go from radical form to exponential. Oh, yeah, there you go, guys. This is, oh, sorry about that. This is a to the 5/2, guys. A to the 5/2. Remember, it's the radicand raised to the exponent of the radicand over the index of the radical. How about B? What would this be? y to the 4/5. Very good. How about C? You got x to the 3/4. Very good. How about D? B to the 3/5. Beautiful, guys. Well done. Not as bad as you had anticipated, right? It's not that bad at all. I just think that the first day I gave this to you, I think it was just a really long lesson. And I think at the end you just were just, a little frazzled. And I get it. It's too long. Too long of a lesson. So I apologize about that. Sorry if I made you think this was more difficult than what it was. Okay. Now, what is each number to the simplified form? Now, we're going to have to go all the way here, guys. So now we're going to use all of our skills to simplify, okay? So, what's the first thing you think I do here, gentlemen? Yeah. So I go 1 over 16 to the positive 2/5, 2.5, sorry, which then would equal 1 over 16 to the 5/2. 2.5, sir, is not 2/5. 2.5 is 2 and 1/2, which when you convert into an improper fraction is 5/2. 2.5 is not 2/5, guys. Excellent. Okay, but that's still not 2/5. That's the square root of 16 to the 5th. Thank you, sir. Vocabulary in math, guys, is important. Just like in English. You don't say that an object is a verb. No. Now, a lot of times people tell me, oh, but that's what I meant. And I get it. I do. I really understand what you're saying. That's what you meant. But remember, guys, you have to know what you're saying. So please try to be careful with that. And thank you for your honesty. So now this becomes 1 over the square root of 16 to the 5th. Okay, so how does that simplify to? No. This would be, what's the, well, actually, yes. Well, no, let's think about this. What's the square root of 16? 4. And then what's 4 to the 5th? What's 4 to the 5th, guys? Okay. All right. 1024.
I'll do it right now.
No, you're right. Good job, brother. Yes, that is correct. Because, yes, that is correct. 4 times 4 is 16, times another 4 is 64, times another 4 is 256, times another 4 is 1024. Great job. All right, for number B, for letter B, what do we got here? What do we do, brothers? You don't multiply anything. You don't multiply or combine anything here for B. This is the 5th root of negative 32, which is in parentheses, to the 4th. So what's the 5th root of negative 32? Negative 2. And then what's negative 2 raised to the 4th? What would it be? 16, yeah. It's not negative because it was inside of parentheses. And those parentheses, that negative got affected by that 4th root. So well done. Well done. Okay, how about C? Very good, my man. This is 1 over 32 to now the positive 3/5. Beautiful, son. That equals 1 over the 5th root of 32 squared. What's the 5th root of 32? Oh, cubed, sorry. What's the 5th root of 32? It's 2, and what's 2 cubed? 8. Excellent. Great job, my man. How about this one for D? Great. 1 over 9 to the 7/2, which then equals 1 over the square root of 9 to the 7th. What's the square root of 9? And what's 3 to the 7th? Man, you are on fire here, kid. What did you get? Oh, yeah, let's see. Let's take it. 3 times 3 is 9. Times 3 is 27. Times 3 is 81. Times 3 is 243, right? Times 3 then, uh,
729.
729. Times 3 is 2187. Excellent job. Does that make sense, boys? Gentlemen?
Yeah.
Okay, next. Now we get the good stuff. All right. Remember that when I have a power raised to a power, I must distribute. So that means that I have to distribute this 2/3 to everything here, guys. So this is really going to become -8 to the 2/3, x to the 2/3, and this is xy to the 1/2 times 2/3. Does everyone see what I did there? I got rid of that square root symbol. I didn't get rid of it. I'm sorry. That was very poorly phrased. I converted the radical into a fraction, a fractional exponent. Yes, sir.
How could you split like you treat the -8 and the x separate? So
Yeah, you could have, if you so chose, my man, you could have easily, since the 8 and the x have the same power, you could have absolutely, my man, done this. -8x to the 2/3. That's totally fine. Now, this is going to be the cube root of -8x squared, right? Times, okay, 1/2 times 2/3 is 1/3. So the cube root of xy. This then simplifies. What's the cube root of -8? -2. And what's -2 squared? Okay, so I got 4 here times a cube root of x squared because I could not take the x out. Times the cube root of xy. Are we allowed to multiply these two radicals?
no.
Absolutely we are because they have the same index. Can we add these two radicals? No, but we absolutely can multiply them, so this would become 4 times the cube root of x cubed y, which will equal 4x times the cube root of y. Easy peasy lemon squeezy. For B, what do I get? You can, but me personally, I'm just going to first go, this is 16 to the -3/4 y to the positive 24/4. It is 6, but I want to try to be a good teacher and show everything. Thank you. So this is 1 over 16 to the 3/4 times y to the 6th. That's going to equal 1 over the 4th root of 16 cubed times y to the 6th. What is this 4th root of 16? 2 was 2 cubed, 8. So my answer here is y to the 6th over 8. Does that make sense? Yes, sir, my brother. You may be able to do it a different way. Some people go ahead and make the 8 positive by bringing it down. Sometimes you can flip the inside and make it 1 over 16 y to the -8 raised to the 3/4. There's a lot of different ways to do this. As long as it's mathematically legal and sound what you did, I'm not going to make you do it exactly how I think. That's why I teach you methods. You do it the way that you figured it out. That's correct, mathematically legal. Okay. Next. Alrighty. How about C? What do we got here? You could do that. Okay. What he's going to do is he wants to change. Oh, I'm sorry. I don't know what's going on with my technology right now. What he's going to do is what he remembered from when we were talking about exponents. And he's going to make the inside here 1 over 8 x to the 15th. And he's going to change the sign of the exponent. You can totally do that. But there's a big warning here. When you do this to change the sign of the outside exponent, do not change the sign of the inside exponents. If you do change both, you did nothing. You did it wrong. So please be careful with that. If you don't like that, just distribute by the negative 1/3 like we did before. So now this is going to equal 8 to the 1/3 down here in the denominator, and then x to the 15 over 3, which equals 1 over the cube root of 8 times x to the 5th, which equals 1 over 2x to the 5th. Does that make sense? Yes or no? Maybe, kind of, sort of? All right. And last but not least, I got the square root of 9x cubed times y. Whoa, whoa, whoa. I don't like the way I just did that. I went too far here. Wait a second. Come on, Moro. Pay attention. This is 9x raised to the 3/2. Sorry, I was going too fast. Then I have y to the 1/4 times 3/2, because I converted this fourth root into an exponent of 1/4. Now I have the square root of 9x cubed times the 8th root of y cubed. Because 1/4 times 3/2 is 1/8. And then from here, what's the square root of 9? 3 cubed, 27. Square root of x cubed. But I can pull out an x from that, so this is 27x times the square root of x. Now, technically speaking, that x should be on the outside in absolute value, but at this stage in the game, we're going to assume that all variables are positive. Times the 8th root of y cubed, because I cannot simplify that. My brothers, does that make sense? Please ask. I got a couple minutes. I got time for anything you need. Talk to me. Yes, sir. The x to the 5th on letter C. I'll change the color so we can know what we're talking about. I'm not being sarcastic, but what's 15 divided by 3? That gives you my 5. Thank you. See what happens when you ask questions? You get answers. I'm proud of you. Yeah, what is 15 divided by 3? Buddy, okay, stop trying to complicate it. Look at the board. Isn't this x raised to the 15/3? What is 15 divided by 3, my brother? That would be x to the 5th. I'm already in the denominator. Does that make sense, my man? Thank you so much for your honesty. I appreciate that. Okay. Last page. Okay. Evaluate each expression if possible. 25 to the 3/2. I'm going to go ahead and speed up on this. This is the square root of 25 cubed. What's the square root of 25? 5 cubed is 125. Beautiful. Great job. Letter B, this is the cube root of 64 squared. What's the cube root of 64? What's 4 squared? Yeah, 16. Great job. Negative 9. Okay. This is the square root of negative 9 raised to the fifth power. Uh-oh. We can't have a negative. And when I have a negative raised to an odd power, that's a negative. So what happens here? We talked about negatives. I. Very good. So what's the square root of well, first take out an I. What's the square root of 9?
3.
3. And then what's 3 to the fifth power?
Negative.
No, it's not negative anymore, son. This negative came out as the I. So this is 243 I. I know the bell rang. You may go to lunch. I'll finish this up now. Thank you. God bless you and have a great day, guys. Hope you learned a lot. So negative 8 to the 4 thirds, this is going to be the cube root of negative 8 parentheses to the fourth. So there are 4 sets of negative 8 here, so I can pull this out as a negative 8 cube root of 8. Actually, you know what? That's going to be way too difficult. Let's do it this way. The cube root of negative 8 is negative 2. Negative 2 to the fourth power, 2, 4, 8, 16. So this will equal 16. This guy right here. Here's the square root. Sorry, I don't know why my board is acting up like this. This is the square root of negative 81 x raised to the 7th power. Okay? It's going to be the 7th power again. So we're going to have a negative. I got to get rid of this negative because I'm in a square root. So right off the bat, I take out the I. And I got the square root of 81x to the 7th power. So I've got square root of 81, okay? And the square root of 81 is 9. So square root of 81 is 9, and 9 raised to the 7th power is a big number. So this will be 4,782,969 I square root of x to the 7th. But I can take out some x's here. 2 goes into 7 3 times. So I've got 4,782,969 I x cubed to the square root of x left over. And then last but not least, I've got 1 over 8 to the negative 2 thirds, which equals 8 to the 2 thirds, which equals the cube root of 8 squared. The cube root of 8 is 2. 2 squared is 4. And ding dong, the witch is gone. Thanks again. Thank you for staying. God bless you all. Hope you learned a lot and have a wonderful, wonderful day. Bye-bye.